So yeah, welcome to the first in a while installation of Brown Bag Lunch. We'll try to have these once a month at least. Follow the Slack channel Brown Bag Lunch if you want to talk about something or if you have ideas what we should bring up or some good presenters. Today we have Julian from the DP team talking about service mesh with Istio.
Thank you. Before we start, I'd like to know what I should explain more. Like, do you understand a bit containers? First, more or less, yeah. Okay, so we're comfortable. Do you understand Kubernetes a bit? Like, can you deploy something to Kubernetes? All right. So you have the basic. That is good. That's the first step. So yeah, I'm Julien. I've worked at those places, but I have a last question. I know you're eating, so I'll be brief. But how long do you think it takes to go from a monolith to a microservice architecture?
Forever.
10 years.
Yeah,
You never reach it.
yeah, years. And even when you're there, it's rare that you still have the core of the monolith that still lives, and so it's really hard to get rid of it. But the reason it's hard is because suddenly you have to deal with the network. And there is this 8 fallacies of distributed computing. And if you look, like the first one is the network is reliable. That's the biggest lie anybody has ever tell you, is this one. Because it's as reliable as it can be. And that doesn't mean that you can rely on it. It's reliable, meaning statistically.
But no one here believes that. We're practicing all the time.
Yeah, and that's why it's called a fallacy. But yeah. And the idea is that if you go look at that RFC, it was written 22 years ago. It's 3-page long, and it's a 12 networking truth. If you want a good laugh, I highly recommend you read it. It has some kind of a basic truth that you cannot go faster than the speed of light, for instance. Or, it's quite nice to read. But so the once you split into microservices, you have this deployment problem. So how do you make your deployment reliable? And mainly, the container come and provide a standard API. You write your manifest, you build it, and you ship it. Basically, a container is nothing more than a zip file or a tarball with a dependency inside. And it relies on the Linux kernel feature to isolate, to provide some level of isolation towards what it can use and what it can see. And people at Heroku, have you heard of Heroku? This platform as a service? So they came up with this 12-factor app, which is is a 12 principles or rule of thumbs that you can follow in order to make your app more, I would say, environment agnostic or containerized in a way. And so that facilitates a lot the deployment, because suddenly you're just passing a container image around, which are basically zip files with a standard API, of course. But that doesn't solve everything, like the deployment concern is how do you scale them up and down? How do you provide redundancy for your application? And let alone how do you schedule them over the cluster? If you have maybe more than one cluster, how do you check that an application is actually working as it should? And the secrets and the configuration of those apps also needs to live somewhere. And so that's where Kubernetes comes into play. If you have Kubernetes solves those problems. Like it's done. But Kubernetes doesn't solve everything. It's a very good platform that everybody can agree on. Kubernetes is a bit like all the sysadmin have gathered up the bash script and made it into Go and give you an interface, an API that you can call in order to have those features. But it doesn't tell you anything about logging. It doesn't tell you anything how to do tracing and about circuit breaking or like fault injection or even for service identity. How can you make sure that the service calling another service is actually the service was claiming to be? And so to solve those problems, developers use code because that's the only thing they have control over. The problem when you use code is that you have an explosion of library, language, frameworks, version, and you have to keep that up to date, you have to patch, you have to change, you have to make them talk to each other. There is always discrepancy, there is always something to maintain, migrate, retire. To introduce a new language in a company is near impossible sometimes, because everything is so streamlined. It's a one size fits all, and that makes it really hard to pick up the right tool for the right job. Let alone when you have to test those features. You know, the test starts to look horrible, and they usually takes more. It takes more time for a developer to write tests to test those features than to actually implement a business logic or deliver value. And I'm not even talking about debugging. I mean, I wrote retry logic for once, and the first thing you learn is that you probably DDoS. You're gonna DDoS yourself if you make something. You know, if the state is not right, and suddenly you have thundering herd, and you bring your own service down just because you wanted to make it reliable, which is like totally the opposite of what you implied. So yeah, and so the idea is that instead of having this code split out in like all the repository of the company, why not make it one single piece and maintain that? Provide an API for that. And so we move it to the infrastructure. And this is where this project came, called Envoy. It was written in C++ to provide performance, high performance throughput. And it was built by Lyft, the ride-sharing company. So basically, they had enough of the writing network libraries for all the language of the company, and they just gather around and make something really reliable about, okay, how can we break down our monolith? It was a PHP monolith in a way that is it's like a migration, like sustainable. And so the goal of the project from the get-go was the network should be transparent to application. And I'm going to show you a quick demo of Envoy. So does anybody know HTTP bin? It's like a nice little application that, depending on the path you're querying, is going to send you back whatever is in the path. So I give you an example. For the, oh no, it's not this one, it's this one, status code. If I want to have a service that's will send me a 200, I just go here, goes 200, and it send me back. And I can see the header, I can see all the format. So this is basically like, if you call status code 200, it will send you back a 200. If you call 500, it will send you back a 500. Nothing fancy, super useful to debug. So this is a container, as you can see, running, this is HTTP bin. So what I'm going to do here, I curl that HTTP bin on a path called, on a path called header. So what it does is send me back the header. The reason why this is interesting is that, what if now I want to call Envoy? I run Envoy and poof, Envoy crash. And the first thing it says is, at least one of the config path or config YAML should be non-empty. So meaning Envoy doesn't work out of the box. You need to configure it. You need to tell him what to do before you ship it. So the way you configure it is through something called YAML. I'm sure you're familiar with it. And this is what it looks like. So you can define access logs. You can define the socket it needs to listen on. You can have the admin interface. But basically, what you want is, telling, okay, whenever you query that port on Envoy, route it to that HTTP bin service. So this is what it does. So if I query now, so you see here I curl HTTP bin directly. This is the HTTP bin, but now what I do is I query the sidecar, which is Envoy. And what it happens here, Envoy has added an extra, what do you call it, headers. So it can rewrite things on the fly whenever you query. So it becomes a really powerful thing. When you want to do stuff like here is, for instance, after 15 seconds, trigger a timeout. So now you put something in front of the service that you call, and that lets you implement some kind of logic and routing feature. So that's a little bit what Envoy does, and you can do interesting things, notably doing fault injection. So here I query the 500 status code, and if you look at I can get some metrics saying how many 500s did I get. And here it says that it retries 3 times, meaning that you have out of the box retry logic in the proxy. So you don't have to put it in your code. You can just configure the proxy. Say for every service I call, retry 3 times. If I get a 500, or timeout after 10 seconds or 200 milliseconds, if you have really performance critical microservices. The good thing is that it's quite nice to have those metrics, because then you know exactly how much traffic is going through your proxy at any given time. And that's a really useful information to get. So that's a little bit about Envoy. Do you get a feeling of the usefulness of this tool? Okay, cool. So now this is the purpose of a sidecar. It's called a pattern, because you instead of service A calling directly another service A. Well, anyway, service B, it goes through the proxy, and that allows to see exactly how much traffic, what are they doing, what are they calling, having some statistics about what's going on and who is calling what. And the thing is that how do you manage that fleet of proxy? Because if you have 100 microservices and maybe some of them have 5 instances of each, you might have like 500 proxy to manage. How do you tell each one which route to go and configure? This is the service mesh. This is the purpose of a service mesh, is a control plane that lets you configure those proxy. The thing is that there are many components here. I will explain those later. It's the base of Istio. So this is the service mesh. It lets you connect, secure, control, and observe all your microservices. They can be either running in Kubernetes or not, but mainly the main use case is for Kubernetes. And so when people ask what is a service mesh, or what is product X, I like to answer by what problem does it solve. And the problem it solves is the communication between services. Is now you can define a network for services, not for byte. No more IP, no more low-level interaction, because when you are working on the business level, it's too much cognitive load to think about those. Doesn't mean they are not relevant. It just means you don't want to take care of this up front. You want to take care of it when you have not working. And so how does it solve this service-to-service communication? Well, for every request that the service make, another request is sent to here the mixer. The mixer can also have is in charge of controlling all the policies and connection routes to all the proxy. So you can see that you have a lot of coming and going. All that traffic is actually doubled now, because for every call that you make to another service, a call is made to Istio, or well, specifically in this case, the mixer. You can also have adapter, because HTTP might not be the protocol that you use. You might want to have TCP, gRPC, or Kafka, or some other binary protocol that you want to filter. And so that's why they have those adapters. It's actually not, everything is written in C++, but it's more scary than it looks, because they worked on the API for many years, and they make it like easier to understand. I'm sure most of us could just read the code and kind of get a feeling of what they do. And the interesting part is also this Citadel here. Citadel is what's in charge of this TLS certificate, because now I have a proxy here. Why would I have a proxy manager in my app when I could just encrypt the traffic between the proxy? I don't need to care about that anymore. My app just say, I want to call some service. Just deal with it. And the proxy say, okay, I will encrypt, I will sign, I will redirect, I will route, I will retry for you. And so you see, like the amount of code that you remove from the amount of concern you remove from your application, and I would say the business logic is huge compared to what you can put if you have a well-written piece of software that does that for you, that you can separate from the business logic. And so this is more like a technical detail, but of course there is a cost for that, because the proxy doesn't run for free. You need some CPU, you need some RAM. The RAM is about 10 meg, so you know nothing to scream about. But the CPU is about half a vCPU per service. So if you have 100, that's 50 vCPU you need to allocate to just that. The cost might be minimal compared to the feature it brings. But as you can see, if you go to the lower layer, this is where the least CPU is going to be required. If you do HTTP routing, this is going to be more CPU intensive, because for every packet that you receive, you're going to need to go in user land and have some code that decide where to send that packet back. So that's just a little bit about the technicalities of the, it comes with a cost. It's not for free, but it's really nice. So yeah, the control plane. You can imagine that service discovery, DNS basically, is kind of coming out of the box. It's quite easier. Like you don't need to know the URL of a service. You can just give it a name. And this is why, like, my first question when I saw a service mesh, I say, okay, but how should I write my application to use that? And basically, you don't. That's the beauty of it. You just call, and that's the URL. Like, it's not even like a URL. This will be replaced by the proxy by with an IP and be sent to I don't care, because now it's the role of the proxy to deal with that. And so you can start to do interesting things, because now, if I want to make some routing rules based on the HTTP header, for instance, if you have the JWT token, it's probably encrypted into a HTTP header, and because Envoy understands HTTP, you can say for every for the header that match this end user field called JSON, route it to the version 2 of the review service, or as you can see here is a YAML, but I'm sure you can understand. Or all the other traffic, send it to V1. So that's interesting, because now you can pinpoint per user which service it can call. So you can have multiple versions, you can iterate, you can do canary release, you can do many, many things with just a few YAML line. And of course, resiliency. I mean, these 3 lines here saying like, okay, retry 3 times if there's an error. This 3 line here is probably thousands in the code that are removed. And of course, there is mutual TLS. So everything can be encrypted. You can have different policies enforced on the HTTP header level, on the TCP level, on whatever the adapter you use is supported. And of course, the beauty of it is, since you know all the traffic that's going in and out, you now have nice observability. Yeah, you know if a service was called or not. Doesn't mean that the proxy never failed, but at least you're better off than just wondering if the library really did its job or not. So yeah, now I'm going to show you a bit of the demo of service mesh. I can kill all that. Yeah, bye. Let's go to Istio. So the first thing I would show is, oh yeah, 7. All right. Okay. Console, that's all. Oh, lost connection to pod. It killed in the middle of the demo. What is this?
Use up all the CPU.
Yeah. No, but I have to. Maybe I didn't give enough CPU. That's the problem as well. So, all that I can do. Istio system. Connection was refused to the server. Did someone kill my server? Okan? Are you? Okay. No. It's upgrading in the middle of the demo. I could not have planned that worse, actually.
So how to upgrade on that one or what?
I cannot. It's in the middle of an upgrade. I should have, that's the problem when you create those like cluster without specifying the. This is a shame. I will show you how to install Istio on a new cluster then. What is this? No. I want to create a cluster. Let's go to Europe North. Latest, maybe 4, 2 CPU. That's really, really lame. Next meetup with Google, I'm going to tell them. Yeah, it's not ready. We need to wait 5 minutes for the cluster to be ready. But in the meantime, I can explain a bit what is this, like the underlying architecture of Kubernetes and how does Istio leverage Kubernetes. Because Kubernetes in itself is basically etcd. It's a database. It's a key value store. When you talk about Kubernetes, that's what we call Kubernetes, the Kubernetes master. And what is that inside that database? Is a state of your cluster. And you have two parts. You have the state, the real state of the cluster, and you have the state you want to see in the cluster. So whatever the kubectl apply you send to Kubernetes. Everything is done through this API server, which basically, serialize JSON and do some convert YAML, whatever. This kubelet here is the one that. This kubelet here is the one that connect with the local Docker daemon here. So when you create a pod, basically it's the kubelet that is in charge of the pods on that machine, on that virtual machine. C advisor is more like gathering the metrics of all those pods to see if they are alive and well. And you have the kube proxy that allows the user to connect to those pods. And everything is connected through the underlying plugin network. So you can see that whenever you make a change, so for instance, I say, I want this pod to be deployed. Kubernetes is going to check in its database, what is the state of a cluster? You say, I don't have a pod. Okay, I need to reconcile the state of the cluster with the state the developer wants to see, merge, reconcile it, it's called, and then apply whatever is changed. And he has some retry rules saying, okay, I can retry that many times before I send the message fail or not. And so the idea is very much to be eventually consistent to whatever the state is wanted as opposed to the state that is inside the cluster. And that's quite it, basically. There is not much more. When you want to see it's basically a while true loop that just check, okay, what is the state in the cluster, what is the state I want to see, and every time it's try to reconcile all that inside the controller manager. I think they could not have chosen like a more generic word for that piece, because I can basically tell, it's like utils, you know, you can put whatever you want in there and be totally fine. Scheduler is more interesting because you can have some, like you can be sure that whatever you put in a pod will be on the same host. So in a pod, the container share the file system and the network. So you know, if one pod is calling local host, if one container inside the pod is calling a local host, it can reach another container inside that same pod. So that's the idea of pod. The name pod is coming from basically, you know, the whales. When a group of, you know, Docker symbol was a whale, and say a group of whale is called a pod. That's where the name come from. So it was like the idea of having more than one container being together, like instead of, you know, people shoving more than one process inside the container. So that's a little bit of why we get the concept of pod instead of just containers. But the scheduler is going to check and see which host fits the best. And for instance, even if the total amount of memory of the cluster is enough, if you have like 10 giga left of memory and your apps only require maybe 6, it might not be able to schedule it because it's 5 and 5 on each host. And since the pod needs to be on the same host, it might just say, no, not enough resources, even though the total amount of the cluster is there. So, all right, we're in business. So, you're gonna be, actually it might be a good thing that you see how it is to install this Istio, because it comes with, so yeah, you have to create a namespace because Istio will be installed on Kubernetes. Then you need to do, oh, it's the JSON, sorry. Yeah, you need to install what they call the CRDs, so custom resource definition. There is about 53 of those. So, you know, Kubernetes come with an extensible API, and Istio team has extended that by 53. So you have quite a lot of API to deal with. The second thing you need to do is to, now this is the demo. This is the installation of Istio. You have pod disruption budget, you have config map, you have secrets, you have service account, you have role, cluster role, job, cluster role binding for everything. It comes with its own Prometheus. And I installed a few extra plugins so that we get some, you know, nice feature out of the box. But that's how you install Istio. All right. Can you read, by the way?
Yeah.
So yeah, it takes a while to container creating. I guess we'll give it a little bit more time. Then after that, once Istio is installed, I need to tell him, okay, now for every application that I'm going to deploy in that namespace, I want you to automatically inject the sidecar proxy so that you don't need to add it manually yourself. You know, it's transparent to the YAML. The way it works is that for Kubernetes, in the controller manager, you can do what they call admission controller. So meaning whenever the API server receives some request, you can have some code that is run through and read whatever the request is, and define some extension, some more advanced or fine-grained requirements. the danger with that, it's like triggers in a database. You know, you can really, it can damage a cluster more, but for authentication, it's the perfect use case. And they use that notably for Istio. And if you look, maybe I can show here. Maybe in a bit of color won't hurt. So as you can see, this is the variable of the proxy. This is the container that was deployed. It's a few lines, and these are all the resource of the to be able to talk through the proxy, because by default it's enforced. So even if the app say I want to talk outside and not talk directly to the proxy have to authorize it, because it's basically by IP table. They just say, okay, whatever traffic is, it has to go through the proxy. And that's how this is the init container. So in every pod, you can define, okay, every time I start this pod, I want those containers to run first. That's called the init container, and that's what is going to trigger the setup of the IP table so that your application always talks to the proxy. So let's see how it's going now. Yeah, seems running. So now what we can do is deploy an application, and it's just a few services, nothing fancy. But the problem is that I can't talk to the application yet, because I haven't told the proxy how to reach it. So that's, again, it's a bit more work, but then we create a gateway that opens the door to traffic to go inside the application. And then I define the destination rules so that everything is set up. Like, I need to open the traffic to inside the cluster, and then define how the application may talk to each other, because you can define deniers, meaning I absolutely don't want that service to talk to that service. Usually it's in front of a database, you know, or whatever. You say, okay, nobody else than this service can talk to that database. So there is no cross-cutting or those things like that. And as you can see, maybe I can. So I just have one container that I define in my YAML, but here there is two. One of them is the proxy. So for every application, you have also that container proxy. We can look, describe details. Oh, pod, sorry. Yeah, you can see it mounts the certificate. It has the proxy for the configuration of the proxy. Although Envoy doesn't really rely on files to be configured, and that's one point, is through HTTP you can configure it to be, so the routes are really dynamic. And that's the biggest pain for service like Nginx or things like that, is that to be configured dynamically, before we had to build their own server that's gonna read to the file and restart the Nginx inside the container, and you might lose some data because there are some inbound requests that are still ongoing, and so that's really tricky. But because they know the pain of that, they made it so that you can configure it through HTTP request. So there is an admin endpoint in every proxy that Istio use to configure the route. Where was I? Is everybody following? Is it already, or is it just the food that is? Because okay. So, all right. So I did the destination rules. Let's check. Yeah, unchanged. Okay, cool. Now we can check for to see what is the endpoint. Oh. All right. So this is my new. Yay! So this is the basically Bookinfo animation application that I just deployed. And as you can see, whenever I refresh the page, there is the star that change. That is because I will show you the architecture. There is 3 versions of the same service deployed. So it just round robin through them all. You know, basic Kubernetes feature that is not at all what, that's not specific to Istio, that's what I mean. So whenever I just move through there, the interesting part now, is I want to see a bit what's, because it's kind of hard when you have to keep everything in your mind or everything in Confluence. It's really hard to see what is deployed. So that's why they made those tools like Kiali that I can hopefully reach. Yes, that's a good sign. You know, like I'm a security guy. No, but that's the default, and all those things need to be hardened actually. But what's really nice is now I get the graph for free, thanks to the proxy, and you can get some really interesting, like the number of requests per second, or the request percentage. But for that, I need to generate some traffic. So let's do that. I think it's template. Yep. So it just triggers a curl on that URL, and let's see what's happening here. Okay, I got some traffic. So right away I see the percentage of traffic, and you can see that now 33 is just round robin through those version of the review service. Maybe the number of requests per second is a lot less impressive. Response time, that's quite interesting when you want to see 9 milliseconds to reach and all those things. Request percentage, that's what I want to show. That's the version, and this is the killer feature, it moves. Yeah. You have no idea how much contract has been signed thanks to this little widget thingy. But so yeah, but it's quite nice to have like a real view. This is like the data is coming from directly from the application. There is no configuration that has been written somewhere that just tell you that. This is the real data. And so, yeah, thank you, cluster. The idea is, oh, sorry. Oh. So, oh yeah. Now the idea would be that I want to pin to one version. I don't want to have those round robin through all those versions. I can just all right. So now I created those what they call a destination role, and what you're going to see here is that the traffic is going to be stuck onto one of those versions. If I configure it correctly, hopefully. Yep, you can see that all of them the traffic is shifting to 56% into the version 1. It's just refresh every 10 seconds, so it might take a while. But so you now have a very fine-grained control over where the network, where the traffic goes, basically, with very advanced, fine-grained vision about what's happening and what is allowed to do, basically. So yeah, you can say that. You have any question,
So
by the way?
animation is wrong.
Sorry?
Oh no, it's a 10-second.
Yeah, it's
delay.
because, yeah, I don't want to hammer that button too much, and I just let it.
But it still says 50%.
Yeah, because that's another service. I just pinned the version of old service to version 1.
Okay, so it's still round robin up there.
No, that's the application that really calls that service. But this one is one call that was round robin through those three. And what I say is like, okay, I don't want those two versions. I just want this one, version 1. And for the purpose of this demo, I just want to pin that to, let's say, I want to test a feature like my version. So what I do is, for my user, or for JSON user, I can go and let's see if I can. So you can see here that the stars don't change anymore. But if I do this, now I'm gonna log myself with JSON, and you can see that now the stars are black. So I'm working on a different version that every production user is having. So that's a bit kind of nice feature when you want to debug. You can of course do canary release and say, okay, 1% of the traffic, 10%, 25, whatever. This is how you can do. I don't know how to come out of this. I don't know. Yelp. Where is my browser? I lost my Chrome.
Oh, it's full screen on the.
Oh yeah, it's in another screen, right?
Yeah.
How do I get that? I don't. Can do somebody
Control.
know?
Control arrow to the right.
No. No.
Try to swipe it.
Swipe
to
it.
the side.
Which side? The other side.
Yeah, the other side.
3 fingers. Oh yeah. Ah.
I think I rewrote this.
What if you just close the incognito tab? No, that was the.
Yay! This was the thing. Yeah, okay, that is still going on. So, yeah, and the interesting thing is that just imagine you're working on this version by yourself, but you discover that there is a security patch that needs to happen right now for your user. So what you do is you want to migrate all the user, just not you, because you're working on a part of the code that might have nothing to do with that. So you can do this, just say, okay, just migrate all the user. No, just, that was the wrong thing. But let's just say that you want to test the system to see how it will react. Forget what I said before, but yeah, and now I'm logged in as JSON, and I introduce a 7-second delay for the product. And you can see that normally here it should appear that an error has occurred. If I refresh, please. No. There is an error here, but it doesn't seem to catch it here. Oh, because I'm on V2 or what? Oh no, now, okay. So yeah, he find out that there was an error on this service. So you get to see really like live whatever kind of error you might have in those proxy. And I think that's all I had for and all that your user are undisturbed. So you can work on seeing how the system reacts under certain condition without ever disturbing your user, and you're doing that in production. So this service mesh technology is quite, I mean, it requires some work to be set up and configured correctly, but what you get is tons of feature that would take probably years to develop in-house. So you just reuse whatever, you can contribute back as well. There is a lot of doc to be written. They have tons of use case, and the documentation is actually really good. And you can try it yourself just by spinning up a cluster and trying out a bit whatever is. So yeah, and there is not only Istio. You have also like this is Envoy, but you have Linkerd, you have Console, and you have Weave Mesh. I don't really know about Weave Mesh. I just saw that Linkerd is dead easy to install, much easier than Istio. Like you have the command line, you just do Linkerd install, and you just install it directly to your Kubernetes cluster. The difference with those two is that this one was written in Scala, this one is been rewritten in Rust, so the performance is much higher. Those one was very much for living on the VM with machine that already has like gigabytes of RAM for those JVM app. And Console, not all of them has the same amount of feature as Istio, but they come like with some of it. Like you don't have to install the whole thing. You can just have for observability, or if you just want encryption, you can just install that. Or if you want the routing, which is like basically the best feature, the more advanced feature that Istio provide. If you want traffic shifting, canary release, circuit breaking, all those things, then Istio can work with that with I would say not too many effort. There is some caveat though, because as you can see, you can have the proxy can trigger timeout, but sometimes a timeout from the remote service can trigger a 502 response in HTTP. So it's not a system, an OS call. You have to adapt those kind of answer to that. Sometimes this might be viewed as some error from the service, while it might be an error from the network. That's the only difference. You still need to know a little bit what's going on under it, but for 90% of the case, it's just abstracting the network away. Do you have any questions?
Is there any company behind this too?
Google. They are the main contributor.
But it's open source.
Yeah.
But
yeah.
Founded by them.
There is a committee. It's not hosted by the CNCF, as opposed to Kubernetes is hosted by the CNCF. So this is still an open source product, mostly by Google, but a lot of other companies like IBM, exactly. The interesting story about Istio is that so Google went and asked all the customers what was the biggest pain point, and there was this one bank that had more developer than Google does. And so they had all this hardware to do this mutual TLS. And you can imagine the yearly budget for the IT department was $13 billion US. $13 billion, just like the yearly budget for that. And by doing that, they say, we don't care about canary release, because who wants a bank that say, let's see how we handle money today, But, they had a very much need for that, and they reach on par performance with hardware by replacing all those Cisco, device, basically. And so they could do, because just think about the amount of time it takes to open a port in a firewall, and suddenly you have a YAML in a repository where people can make pull requests, and someone merge, and it gets automatically deployed. So that's the gain by going from a hardware perspective to a software, with something with an API, basically. You have tons of time and maintenance saved by going that way. So, yeah, that's a bit of the background. I'm sure Google has tons of features that don't come directly through that, but they try very much to to build this in the open so that they can reuse that for the service. And you can see, usually I have to install it, but if you choose, yeah, I don't need that, but here, if you create a cluster that has, you can see the add-on. Yeah. Here, enable Istio. You don't even need to install it. The thing is that you want to leave that as permissive, because this just means that the encryption between services, a service by permissive can still accept some non-encrypted traffic. So the idea is that when you're migrating from non-encrypted to encrypted, you don't want to flip the switch and everything is encrypted. You want to do it gradually. Otherwise, things will blow up. And since everything is encrypted, good luck to debug whatever problem you have. So the permissive is like the transition stage by going from totally non-encrypted to some service encrypted to everything encrypted. And then you can flip the switch and say, okay, strict, and everything is to be encrypted or it's not accepted by the proxy. Yeah, that's it.
Cool, good stuff. Thank you. If anyone could take a chair with them, I don't want to full drag as much myself. Thank you guys.